right, so now let's work on the guided notes for section 6.1. So these are, you can download these from the modules in Canvas, or if you got a hard copy from me, go ahead and pull that out and be completing it as we do this video. All right, so the first part of 6.1, I'm just going to be reviewing how you solve a linear equation. Okay, some of you have had that, but some of you may not. So for some, it might be a review, and for others, you might be learning it all over again. Okay. All right, once we finish that, once we finish just reviewing it, we'll practice with some equations, and we'll see, kind of get a feeling for how that process works. Okay. And then once we do that, we'll be able to try to work through some word problems that are in the section. Word problems like this, where rather than just guessing and checking or using trial and error, we'll be attempting at writing an equation, okay, and then using the equation to solve the problem, okay? So we'll do that. All right, so let me go ahead and get started on the basics. So an equation, hold on a minute, it's not, okay, here we go. All right, so an equation is just a statement that indicates that one quantity, equals some other quantity, okay? So I want you to think of a seesaw at a playground. So there's like a little space here, and then there's a board, and the kids sit, on each end of that. You sit on an end of it, okay? And then you can kind of move up and down. So if the two kids were sitting the same distance from this center point and were exactly the same weight, then that would be balanced. So think of something being in perfect balance. Think of that when you think about what an equation really is. The left side and the right side have the same value, okay? It's in perfect balance, okay? All right, now, our big job is to solve an equation. So a solution to an equation is going to be some number, some value for the variable that winds up making the equation true. Okay? So here, the equation I gave you is 2n plus 5 equals 11. And I'm not asking you to solve it. I'm just asking you, is 3 a solution? So here's the work you would do. You would plug in the 3 and add 5 and then find out, does that wind up being 11? And sure enough, 6 plus 5 equals 11, so it checks. So 3 is a solution. Okay. So here's two questions that I'm not asking you to solve. I'm just asking you to determine if a number is a solution to the equation or not. So that means what you can do is just plug in the number you were given and see if you wind up having the two sides equal to one another. So here on question number 1, I have negative 15 minus 5 equals 10, which is not true, right? Because negative 15 minus 5, that's going to really be negative 20. So it doesn't equal what it's supposed to equal. Okay? So that means negative 5 is not a solution. To the equation. All right, and then on question number 2, we're actually solving an equation involving an exponent. Okay. Only we're not really solving it, we're just checking. So on question number 1, they asked us to find out if negative 5 was a solution. Here we're trying to find out if 3 is. We want to know if 3 works. Like if I plug in a 3 into that equation, do the two sides wind up equaling? So I'm going to work it out, right? We would do the exponent first to get 9, And then 2 times 9 would be 18. And 18 minus 13 does equal 5. So 3 is a solution. 5 is not. 3 is a solution. Okay, negative 5 over here was not a solution because it did not make the two sides equal. All right, now one more thing is our focus is going to be on equations that are more like number 1 than like number 2. Number 2, the exponent is squared. That makes it something called a quadratic equation. Okay, so it's not a linear equation. We're going to be focused on linear equations. A linear equation is an equation that can be written in this form. Some number times x times your variable plus a number equals a number. Okay? It doesn't necessarily start out that nice, but we're saying that it can be written that way, could be put in that form. And the key is that the exponent on that x is understood to be 1. Okay, that's what makes it linear. So let me jot down a couple of examples. So we've already seen one of them, right? 3x minus 5 equals 10. Okay, but you could have something like x equals 2. Or you could have had something like 1/2 of x minus 5 equals 4 times x minus 7. You can have variables on both sides. There could be fractions involved. You can have all sorts of stuff going on to be linear. Okay. All right. Things that are not linear would be things like number 2, and that's because of the exponent, or things like this. Okay, a radical. Okay, or if you had a variable in a denominator, something like that. That's not linear, at least not to start with. Something like that is not linear to start with, okay? So these are examples of linear ones here, okay? And then not linear would be things that can't be put in the form, something that looks like 3x minus 5 equals 10. All right, now these are equations that only have the one variable, okay? In our intro to linear equations, we looked at an equation in 2 variables. I'll show you the connection a little bit later. Okay, so now let's focus on this important process. This is a process that you want to just get kind of automated, that it just makes sense and you clearly see what it is you're trying to do. So it's something that you don't really want to memorize the steps. You want to understand why we do what we do. Okay, the goal is to get the variable equal to some number. They call that a constant. Just variable equal to some number, really. Okay. So our goal is to get something like x equals 5. Okay, that type of thing. Okay. Now, there is going to be kind of a regular process that you use, but you don't really need to memorize it. It's going to be more important that you keep in mind those guidelines, and I'll talk about that in a moment, okay? But the process is going to be for you to simplify each side of the equation. Just get it simplified as much as you can, each side separately, okay? So that's where you're going to be getting rid of any parentheses, and if there are any what we call like terms, we'll combine them. All right, then you're going to work on getting the variable terms, the terms that have variables in them, x's in them, on one side of the equation and the constants on the other. So you'll move the things with variables in them to one side, usually the left, and then move all the constants to the other side. Okay. After you do that, you're going to work on trying to get the variable by itself on one side. So if there was a number in front of it, you'd want to try to get rid of the number that's in front of the variable. All right, now there's going to be certain things you do for steps 2 and 3. On step 2, you'll wind up either adding or subtracting something from both sides, and then to get the variable by itself in step 3, you'll usually wind up dividing, but sometimes you have to multiply. And then once you do that, you can check your answer, which is fabulous, by doing what we did back with questions 1 and 2. We can just plug it in and make sure it works. Okay, that being said, you should not guess and check to try to get the answer to a linear equation. You will not be able to do that on all equations, and it takes too long. So I've seen students in my Math 98 class try to just guess and check their way to getting an answer. And then they don't finish. Somebody will finish 20 questions in the time it takes them to do 5. So work on understanding the process and getting comfortable with it. All right, so here's what's more important. Keep in mind that seesaw we had earlier, where we have two quantities, that are equal to one another like this. And the fact that we have to make sure that whatever we do makes sense, okay? So you're going to wind up needing to undo whatever has been done to the variable. Okay, so for instance, if our equation was that 2m plus 13 equaled 50, then we'd be trying to undo adding 13 and also undo multiplying by 2. Okay. The other guideline to keep in mind is that whatever you do to one side of the equation, you must do to the other. And that's because of the meaning of the equal sign. You need to make sure the two sides are going to still be equal to one another. All right, so let's do the process using this equation. A lot of equations will have that look. 2m plus 13 equals 50. Some number times your variable plus a number equals a number. Very common to be in that form. So what you'll wind up doing is saying, oh, I need to get rid of the 13. Since it's plus 13, I'll subtract 13. But if I do that to one side of this equation, it helps to almost have lines there. Then I need to do that to the other side so that I can keep it balanced. Think about that seesaw. All right, so my result at that point would be that the 13 is gone because it adds up to be 13 and negative 13 cancel out. You get a 0 there. So I have 2m plus 0 equals 37. So 2m would be 37. Then you should be thinking, okay, and 2 is being multiplied by m. I need to undo that. So to undo it, I'm going to divide by 2. But if I do that to one side of the equation, I better do it to the other so that I keep the equation, the two sides, equal. And so that gives me m equals 18.5. And then if it is in context, like that problem was, then you have to interpret your answer sometimes. Like 18.5 wouldn't make sense as a number of movies. So if it were in context, you would go on and say, oh, 18 movies. But if you're just solving an equation, then your answer to that equation would have been 18.5. Okay? And then we could check it, which is so fantastic, by just sitting and plugging in right there where the variable was. Now that we think it's 18.5, we could plug in 18.5 and do that work. Just enter this right here on the calculator and see if we get 50. And then if we do, we know for a fact we're right. But don't try to guess and check your way to 18.5. That takes too long.